We've danced around or treated informally some of the topics that are related to methods, which is to say these things that are descriptions of things that we want to do whenever a particular message is sent to an object. In other words, when a particular method is called. We've talked about it a little bit, but today we're going to flesh out some of the concepts that are sort of closely related to methods. We'll talk about parameters, return types, and local variables, and some other things. This is what the general structure of a method looks like. We have visibility modifiers, the return type, the name of the methods, any parameters it takes, and then all the code that describes what a method actually does. Public is the visibility modifier that we use for a method whenever we want any client to be able to call that method. When we want to make it so that it's a sort of helper method that can only be used within the same class, that's when we decide to make a method private. So generally we'll make our methods public, but if you're making a little method that does something that helps one of your other methods do its job, that's when you'd probably make it private. We'll say a little bit more about helper methods later in this lecture. If our method doesn't return a value, we'll set its return type to void, and that's often the case for mutators, which change an object's instance variables and don't necessarily return a value to us. But if a method's return type isn't void, then we can set the return type to any primitive or reference type or anything. One of the most common types of methods that we'll see that has a return value are accessors or getters, which are methods that just return the value of one of the instance variables of an object. As far as the name of a method, it sort of has the same syntax as other identifiers that we've seen, like variables. You want to pick method names that describe what the method does. Oftentimes, we like to use verbs in our method names. Get average score, set name, print section, things like that. Methods do stuff, and we want the names to make clear what precisely they do. As far as parameters go, you know this already, but whether or not we actually give any parameters, we do have to include parentheses. And inside those parentheses, if we're including parameters, we got to have pairs of the type name and then the name of the specific parameter itself of that variable. And we'll separate those pairs by commas, int change, and so on. Now, the code inside, you're not actually required to have this in order for your code to compile. If you don't include any implementing code, we'll call the method a stub. You might use stubs if you're putting together a big program and you want your code to compile, but you don't yet know precisely how each method is going to do what it does. Then you'd set up the stubs to get a sort of skeleton for your class that you'd fill in as you went along. Let's go into just a little bit more detail on some of those things. First, with return statements. If a method has a return type, then you got to have at least one return statement in your code. And it's got to return something of the same type in your return type in your method declaration. Now, you can have more than one return statement in your method, but just keep in mind, whichever one you get to first ends your method right then and there and returns that value back up to the method that called your method. As an example, this method odd, which is a public method that returns type Boolean, it's got two return statements that are wrapped up inside some conditional logic. So, depending on the parameter that gets passed, will return either false or true. And whichever one we hit first, that's the one that will end this method and send us back up to whichever method called us. Now, if we had a return type of void, then having a return statement would just quit the method and wouldn't actually return anything at all. Okay, so if we're defining and later if we're calling methods, it might be helpful to properly distinguish between how we name parameters in our server-side code compared to our client code. Parameters that we list in a method's definition, those we typically call formal parameters, and values that we pass to a method when we call it, those we typically call either arguments or actual parameters. So that's formal versus actual parameters. Here we can see the setScore method from our student class, and we can see some client code that's creating a student object and getting some input to get a test score, and then actually just inputting that into the setScore method to set the score of the first test. In this case, in our setScore method itself, I and score, we call those formal parameters. Those are in the student class. On the other hand, the values that we actually pass to setScore in our client-side code, that would be 1 and test score here, those we would call actual parameters or arguments. Sort of important to note, score and test score here, the formal and actual parameters, are actually independent of each other. So changing score in the server-side code in our student class doesn't actually change test score, and changing test score wouldn't actually change score after we had already called the method. Last note, when a method has multiple parameters, you got to give the right number and the right type of parameters in the right order. So the actual parameters or the arguments have to match the formal parameters in both position and type. The types have to either be the same or less inclusive than what's asked for in the parameter. As an example, think about the method math.squareRoot. That has a single formal parameter of type double, but we can also pass an int along with a double. We can pass an int as well as an actual parameter or an argument from the caller because that's less inclusive than double. So this begs just a very brief discussion of a really important distinction that we need to draw, and that's the distinction between parameters and instance variables. Parameters have the job of passing information to a particular method from whoever's calling it. On the other hand, instance variables are supposed to maintain information of an object. They're sort of like an object's memory. They're the things it remembers. You can see this in setScore. The formal parameter that we take in, score, all that's doing is sending in a value for this method. Then we take that value and we transfer it to one of the instance variables, which would be either test1, test2, or test3. Those we actually remember. Now, sometimes it's not enough to just work with instance variables, which are available to the whole class, or with parameters, which we get from other methods, from our calling methods, and pass information into a method. Sometimes we need to make some sort of local scratch paper, some temporary working space for us inside a method, and that's what we call local variables. You've done this already at this point, but it's good to give it a name. If you think about the student method getAverage, we have some local variables there. For instance, we declare this variable average, which is of type int, and we do a bunch of arithmetic and store the result in average, and then we return average. Now, we don't need to remember average after we've returned it. There's no really good reason to do that. So after this method finishes running, average, along with any other local variables we might have declared in a method, it all gets trashed. It all goes away. Local variables only exist for the lifetime of that single call of the method. As soon as we return out, all that stuff disappears. Now, sometimes you'll be writing a method, and the thing you're trying to do in that method is so complex that it makes more sense to break it down into a couple of subtasks. But you know that no client, no outside user of an object of your class, no outside client is ever going to have to call that method by themselves. That method's job is really only to support another method that somebody actually would call from the outside. That's when we'd want to use a helper method. And we usually make helper methods private because that means that only other methods in the same class can call that method. No outside client can call it. An example of this might be if you have some method that you're writing where you know you have to constantly sort a bunch of things. Well, then maybe what you want to do is write a helper method that can just handle that little chunked off task for you. That's who you call whenever you need to sort a bunch of stuff. And then once it's done, it gives you back a result. It returns a result to you, and then you proceed with your business. You go about your day. Another example is here if you had a method called debug that just took a little message and a value that you wanted to print out, then anytime you wanted to see what a variable's value was, you could just call that method. In this case, that would look like debug, and then we'd pass the message average and then the actual variable average itself. You could call that little private helper method from any method in the same class. And then when you decide, you know what, the program's done, I actually don't need to see these print statements anymore because I know that it works properly, you only have to change one line of code to get rid of all of them. All you have to do is go ahead and comment out the print statement in your debug method. It's a nifty little trick. It's not the only use of private helper methods, but it is one little example of when you might do it. Before we close up shop, a couple of ways for you to check to make sure you understood. If you can describe the difference between formal and actual parameters and tell me about how Java actually transmits information between methods using parameters, that's a really important idea to take away from this. Try writing a method called sum, which takes two integers as parameters and then returns the sum of all the numbers between the first and second one. And then finally, if you can talk about local variables, what they're for, what the difference between a local variable and, say, an instance variable or a parameter, what the difference between those three is, I think you're probably in good shape for today. That's it.